Hey everyone, my name is John Lee. Welcome to How to Do Great Work. We're going to talk about my journey into becoming a tech lead and a manager and what it means to define great work. So I'm a senior Android developer at Wayfair. I joined back in March, and I have the awesome opportunity to lead some community and cultural initiatives there. And the story starts a week before I actually moved to Boston. I had a call with my manager and I found out that I was going to be the tech lead and manager of the design services team. And I've never had an official tech leadership kind of position. So with a little bit of imposter syndrome creeping in, I decided to prepare by reading some management books to feel a little bit more confident about jumping into that role. I read books like Radical Candor, Manager's Path, $1 Trillion Coach, Measure What Matters. And it was one of these books that influenced me to give this talk. How to Do Great Work was influenced by The Making of a Manager by Julie Zhou. She was a designer who became a manager at the early stages of Facebook. And in this book, she documents her journey as well as what she learned. And so what is a manager? What's the difference between a manager, a tech lead, and an engineer, right? She has a really elegant way of putting it. A manager's job is to get better outcomes from a group of people working together through influencing purpose, people, and processes. As an engineer, the value you give to the company is your contributions through code mainly. As a manager, the value that you give is by increasing the output of your reports. And being a tech lead, the responsibility is somewhere in the middle. It's kind of gray. So the book proposes the question, what gets in the way of great work? And there are two possibilities. One, they don't know what it means to do great work. Or two, they're not motivated to do great work. In my situation, I would be joining a team where the engineers have been working on the Android platform for less than a year. So I focused on fixing that first problem, defining what great work means for my team. So the game plan was outlining core values and defining good practices. And I want to say that's very important to outline core values because it is the thing that guides you through the ambiguity and the gray. Let's say you have 2 or 3 great solutions. You don't know how to pick between them. Use your core values and let them guide you to the best solution. So with our core values, we have Android first mindset, readability, maintainability, and feedback is a gift. All right, so who here, let's take a poll. Who here works in a team of less than 5 engineers? Raise your hands for me. Great. Now keep your hands up if your company has more iOS engineers than Android engineers. A good amount of people. That's my experience in my career as an Android developer. And this has resulted in situations where, since iOS has more resources, they're usually further along in their product development, right? And it has led to situations where the Android team would borrow iOS mocks. Their requirements would be created from iOS requirements. And my point with this core value is that we can't let those things get in the way of creating the best Android experience for our users. So we should keep that in mind. The next core value is readability. In our work, we will be writing documents, we'll be communicating through Slack, we'll be writing emails, writing code, writing pull requests. Readability fits into all of these, and it's important to make sure that whatever you write is understandable. The next core value is maintainability. Writing the perfect code once is a myth. Code changes because requirements change. That happens, we're human, right? And let's say you write perfect code. That doesn't mean that all the other engineers in your organization do also. It's a collaborative environment, so we need to create and nurture a culture of maintainability. And the last one, feedback is a gift. This is another concept I took from Julie's book. Receiving feedback can be hard. Giving feedback can even be harder, but we practice this through code reviews, through peer reviews, through conversation. And feedback is a gift with the opportunity to grow. And we should be able to give that gift with empathy, care, and thought. With these core values guides the formation of principles and good practices. The first one, you might have seen this in plenty of other slides or presentations. Rooted and solid. These are very core programming principles that's relevant to almost every engineer. I'll just go over them very quickly, but there's plenty of resources to dive deeper into it. Single responsibility principle. The idea that your code should be focused and should not do too many things. It should mainly have one concern. If we've ever worked with an activity file with over 1,000 lines of code, that's breaking single responsibility principle. Open-close principle. It's the idea that code should be open to extension but closed to modification. When you write code and you want to add to that functionality, you shouldn't have the need to modify the existing code. Liskov substitution principle. It's the idea that when you have a child class, cast it as a parent class, and you call a shared function, the result or expectations should remain the same. This one is very common if you have a very long inheritance chain. The interface segregation principle is the idea that your interfaces or your contracts should be concise and small. They shouldn't do more than they need to. Dependency inversion principle is the idea that your class's dependencies should be contracts or interfaces rather than concrete classes. It makes it easier to test, easier to switch out implementations, easier to extend. This is so important. So that's solid. So I bring up this quote. I call it my billion-dollar mistake. It was the invention of the blank in 1965. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably cost $1 billion of pain and damage in the last 40 years. So take a moment and think about what's the blank. All right, I hope that's enough time. It is the creation of the null reference. So, which brings us to my next point. We should avoid nullability, right? 99% of crashes are from null pointer exceptions. That's not a real statistic. It's just one that feels very familiar and common when we're actually coding. Having less nullable objects in your code base will inherently make it more stable because you avoid null pointer exceptions. And with Kotlin and how it was designed with working with nulls in mind, we can leverage the language to write really awesome code without workarounds. Now, there's a quote that says otherwise about avoiding nullability. The truth is, the concept of null is not a mistake, but Java's type system that considers null to be a member of every type is. Embrace null in your API design. Null is your friend with Kotlin. There is no reason to fear it and no reason to work around it with null object pattern or wrappers, let alone with exceptions. Proper use of nulls in your API results in more readable and safer code, free from boilerplate. And that's from the guy that writes or leads the Kotlin teams himself. And it's very true. Kotlin was designed to work with nulls very well. And this is a lesson in all the principles that I bring up today. They are not hard rules. They are just good practices and good places to start with. Newspaper prints, credit card transactions, birth certificates, photographs. What do they have in common? The answer I had in mind is that they can't be changed after they have been created. This is the concept of immutability. Now, birth certificates can be a little bit different, where you can update your birth certificate, but as a result, you will have two physical copies of that certificate, the original and the newly modified. Neither is mutable, continuing to follow the idea that it can't be changed. Which brings me to the principle of promote immutability. Immutability is the rule that says an object can't be modified after it is set to initial value. When you limit the data in your app to be read-only, you limit a portion of potential defects or the introduction of defects by collaborators. And it makes sense for a lot of use cases. You have less concerns with immutable data because of how it scopes your code. And there's a bonus perk with immutable data. Immutable data is thread safe. From Uncle Bob himself. If you want to write your code to be easy to write, make it easier to read. Use meaningful names. That's something he coined himself, and I borrowed this from his book, Clean Code, which goes over the entire idea of how to write clean code, how to name things. And naming things could be one of the hardest parts of our jobs. We can spend tens of minutes figuring out a good name and not come up with one. But there are general principles around this, general practices. The goal is the name of a variable, function, or class should make its intentions and responsibilities clear. Good practices around this is that function names should sound like actions. Class and variable names should avoid broad and generic words like data or manager. They could mean a lot of things. And if you want to look further into this, I recommend Uncle Bob's book on clean code. All right, so in this code example, we have a restaurant menu in a view holder, name, description, price. And it works, it looks fine, except for there's a problem. We're duplicating code. What it should ideally look like in the bind method is this. We should be reusing those setter methods. And this goes to the principle of avoid duplication. Don't repeat yourself. It's easier when there's one source of truth, so you don't have to modify logic everywhere. Leave the campground cleaner than you found it, Boy Scouts of America. This can translate for us as leave the code base cleaner than when you found it. Which brings to the idea or principle of fight software rot. When you modify an area of your code base and you see some hacks or you see some code that could be slightly better with minimal time commitment, you should do that, because when there's entire areas of a code base that has been neglected and has aged, it brings about a pattern of not continue to not care about code in that area. And that's something we should definitely fix. Writing unit tests. There are many reasons to write unit tests. Unit tests can give you an additional perspective on how well your class was designed, because they're in the perspective of the consumer of the class. They can tell you if changes breaks existing requirements of that class. And overall, writing unit tests gives you much more confidence in your code. Let's look at the design here. We have a weather app, right? With a forecast view, a forecast presenter, forecast repository, and a weather API. With the weather snapshot acting as the model, retrieved by the repository, passed to the presenter, passed to the view. This code works, but it's not perfect. An example of that is time might be represented as a UTC long from the weather API, but passing that to the view, it should probably translate to a string that's readable. The feels like temperature float might not be used in the view, but maybe a data that's required in the repository. So we're reusing weather snapshot in both the view and repository, but that can be dangerous because requirement changes in your view will require you to change weather snapshot, But weather snapshots also used in your data layer, in the repository. Mixing those responsibility in one model can cause headaches. Ideally, what we should be doing is having two separate models, one for the data layer, one for the UI, so that they are specialized for their use cases. That brings me to this point. Coding by convenience is a pitfall. It's convenient that the weather snapshot, which we use to represent the data coming back from the API, could be used to represent the view, but that's actually a trap because it limits and makes it more difficult to deal with changes from the data layer because it will affect the UI layer and vice versa. These is hard to spot, but we should keep a lookout for instances like this. And overall, on how to do great work. If you're an engineer, check in with your tech lead and manager on how you can do great work. If you're a tech lead or manager, take the time to outline what doing great work means for your team. These principles and core values were specific to my team, but hopefully you can establish that for yourselves. Thank you.